Hello students, now let's continue the arithmetic functions. Now let's see the next theorem. For any n belongs to z plus, that is positive integer, sigma n is equal to the product of p raised to alpha divides n, p raised to alpha plus 1 minus 1 upon p minus 1. Okay, now the proof of this, let n greater than 1 be any integer then n equal to p1 raised to alpha 1, p2 raised to alpha 2, so on up to pr raised to alpha r. That is product of p raised to alpha where p raised to alpha divides in n. Now by definition sigma n is equal to sum of positive divisors of n, that is equal to summation d divides n. If we define arithmetic function f of n is equal to n for all n belongs to z plus, then clearly f is multiplicative function. Okay, therefore sigma n can be written as summation d divides n f of d. Okay, now since this f is multiplicative, sigma n is also multiplicative function. Okay, therefore we can say sigma n is equal to sigma of, what is this? Sigma of what? Product. Sigma n, what is n? N is this number. So product of p raised to alpha divides n of p raised to alpha. N is equal to this one we had assumed. Now this is same as sigma n is multiplicative, this is same as sigma of n is equal to product of sigma p raised to alpha, where p raised to alpha divides n. But 1, p square and so on up to p raised to alpha are positive divisors of p raised to alpha. Therefore sigma of p raised to alpha is equal to 1 plus p square plus so on up to p raised to alpha, and that is same as p raised to alpha plus 1 minus 1. Using binomial, you know this one can be written as such. Fine. Therefore, sigma of n is equal to, if sigma p alpha will be this one, so sigma of n, we have to put the value of sigma p alpha here, this one. This is same as product of p raised to alpha plus 1 minus 1 upon p minus 1, where p raised to alpha divides what? N. This is a theorem. Look at it carefully. N is any integer which can be written as, using fundamental theorem, we can write it as a prime factorization. So now the definition of sigma n, then using one mark we had written it as such, summation of d, where d divides n. Now if we define the arithmetic function will be what? We had assumed this f of n will be n, and also in one remark we had mentioned it as such. Fine. Now otherwise we had used the property of multiplicative function here, and the positive divisors of p raised to alpha are these. So sigma p alpha will be this one. Simply we had put up the value of sigma p alpha there. This is about this theorem, but it is very useful theorem. We can easily determine sigma n for the largest integer here. So let's see the example. So example, find sigma n for n equal to 100, 180, 570 and 1000. So now solution. First, suppose n equal to what? 100. First of all, we need to obtain its prime factorization. So you know it will be 2 into 50, that is 2 into 2 into 25. So it can be written as 2 square into 5 square. So p1 raised to alpha 1 into p2 raised to alpha 2. Okay. Therefore, sigma of 100 is equal to what? Here p1 raised to alpha 1 plus 1 minus 1 upon p1 minus 1 into p2 to alpha 2 plus 1 minus 1 p2 minus 1. So this is equivalent to 2 cube minus 1 upon 2 minus 1 into 5 cube minus 1 upon 5 minus 1. So this is equal to, this is 7, 8 minus 1, so 7 by 1. 7 into, this is 124 upon what? 4. So this is 7 into what? 31. That is how much? 270. This is a value of sigma of 100. Otherwise, we need to obtain all positive divisors of 100 and then we can determine the sum of them. Fine. So this theorem is very important to us. Now, the second one, what? N is equal to what? 180. So 180 can be written as 2 into what? 90. That is same as 2 into 2 into 45. This is same as 2 square into, this is 3 into what? 15. So it is 2 square into 3 into 3 into what? 5. So this is 2 square into 3 square into what? 5. So compare it with p1 raised to alpha 1 into p2 raised to alpha 2 into p3 raised to alpha 3. Alpha 3 will be what? 1 here. Fine. Now we have to determine sigma of 180. So it is p1 raised to alpha 1 plus 1 minus 1 upon p1 minus 1 into p2 raised to alpha 2 plus 1 minus 1 upon p2 minus 1 into p3 raised to alpha 3 plus 1 minus 1 upon p3 minus 1. So this is 2 cube minus 1 upon 2 minus 1, 3 cube minus 1 upon 3 minus 1 into 5 square minus 1 upon 5 minus 1. So this is 7 into, this is 26 by 2 into this is 24 by 4. So that will be 7 into 13 into what? 6. So it is 546. Now let's find out for the next one. N is equal to what? 570. N is equal to 570. So third, N equal to 570. So it is 2 into how much? 285. Okay, that is same as 2 into, now this is not divisible by 2 but it is divisible by 3. So 3 into what? 95. So it is again 2 into 3 into 95 having a factor 5 into 90. Okay, therefore this is P1, P2, P3, P4 and the alphas are what? 1 everywhere. So therefore sigma of 570 will be what? P1 raised to alpha 1 plus 1 minus 1 upon P1 minus 1 into P2 raised to alpha 2 plus 1 minus 1 upon P2 minus 1. P3 raised to alpha 3 plus 1 minus 1 upon P3 minus 1. P4 raised to alpha 4 plus 1 minus 1 upon P4 minus 1. So this is 2 square minus 1 upon 2 minus 1. This is 3 square minus 1 upon 3 minus 1. 5 square minus 1 upon 5 minus 1. And 19 square minus 1 upon 19 minus 1. This one. So this is same as 3 into, this is 9 minus 1. So 8 by 2. So 4. Okay. This is 24 by 4. So 6. And this is, this one 19 square is 361. So that will be 360 by 18. So it will be 20. So this is 1440. Now last one is 1000 is left. So let's determine that. N is equal to what? 1000. So fourth one, N is equal to 1000. So it is 2 into 500. So this is 2 into 2 into 250. That is 2 into 2 into 2 into 125. So it is 2 cube and 125 is nothing but 5 cube. Fine. So P1 is 2, alpha is 3. Fine. Therefore, let me write directly now. Sigma of 1000 is equal to what? 2 raised to 4 minus 1 upon 2 minus 1 into 5 raised to 4 minus 1 upon 5 minus 1. So this is 2 raised to 4 means 16 minus 1. 16 minus 1 will be 15. 15 by 1. Okay. 15 into, this is 5 raised to 4. 5 raised to 4 is how much? 625. 625 minus 1 will be 624 upon 4. So it is 15 into, this is 4 ones are 2, 22. So 4 5s are and 4 6s are. So this is 15 6 are 90. 15 5s are 75 plus 9 will be 84. 8 carry. 15 ones are 15 plus 8 is how much? 23. So this is 2340. This is the answer here. Now one more theorem we have to see. Let's go towards that theorem. This is also an important theorem in exam point of view, or in while solving examples also we are using it. Theorem: for any n belongs to z plus summation phi of d divides n is equal to what? N. So proof: define capital F of n is equal to summation phi of d where d divides n, as the function phi is multiplicative, therefore capital F of n is also multiplicative. Okay. So now let n is equal to p1 raised to alpha 1, p2 raised to alpha 2 and so on up to pr raised to alpha r. That is product p raised to alpha where p raised to alpha divides what? N. Therefore Fn is equal to what? Fn equal to the product of p raised to alpha divides n f of p raised to alpha. Call it as equation number 1, as it is a multiplicative function. Fine. Now our aim to determine this f of p raised to alpha. So this is summation phi of d where d divides p raised to alpha according to our definition. So this is same as, you know, the divisors of p raised to alpha are 1, p square and so on up to p raised to alpha. Therefore it will be phi of 1 plus phi of p plus phi of p square plus so on up to phi of p raised to alpha. So this is 1 plus phi of p plus phi of p square plus so on up to phi of p raised to alpha. So this is equal to 1 plus summation phi of p raised to I, where I goes from 1 to what? 1 to alpha. So this is a simplification of this one according to our definition. Now if we look at here, but what is phi of p raised to I? So this is p raised to I into 1 minus 1 upon p, that is p raised to I minus p raised to I minus 1. Therefore f of p raised to alpha equal to 1 plus summation I goes from 1 to alpha into what? P raised to I minus p raised to I minus 1. So this is equal to 1 plus p minus p raised to 0. P means p raised to 1. Again plus p square minus p raised to 1 plus p cube minus p square plus so on up to what? P raised to alpha minus 1 minus p raised to alpha minus 2 plus p raised to alpha minus p raised to alpha minus 1 as such. So this is equivalent to, if you look at carefully, this is 1, p raised to 0 is also 1, but it has negative sign. So these are get cancelled. P raised to 1, p raised to 1 get cancelled. P square get cancelled. So everywhere here look at this cancel. This one will cancel here. Fine. So only a single term. This is also cancelled with here. So only a single term will left. That is what? P raised to alpha. Therefore f of p raised to alpha equal to what? P raised to alpha. Therefore what is f of n? f of n will be this, equation 1 will become. From 1 we can say product of p raised to alpha divides n of what? P raised to alpha from 1. Okay. Now this gives us this product of p raised to alpha equal to what? N. So this gives us f of n is equal to what? N. That is same as summation. Therefore summation phi of d divides n is equal to what? N. So the same one we have to prove. Fn is equal to n, but what is Fn? Fn is equal to summation phi of d where d divides n, and that is equal to n. The same one we have to prove. Fine. So this is about this theorem. Now let's see one example on this theorem. Let's go towards that. And while taking this example, that will be the completion of our second function, that is arithmetic function or number theoretic function. So example, find the least positive integer n such that d of n is equal to what? 6. So solution, we have to find the positive integer such that this condition should satisfy. So n is equal to, let's assume n is equal to p1 raised to alpha 1, p2 raised to alpha 2 and so on up to pr raised to alpha. That is equal to 2 raised to alpha 1 into 3 raised to alpha 2 into 5 raised to alpha 3 and so on. Okay. Therefore d of n will be what? Already we have seen a theorem. It is equal to alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 into so on up to what? Alpha r plus 1. Product of alpha I plus 1 is here. Now it is given that what is with us? We have d of n is equal to what? 6. And this 6 can be written as 2 into 3, that is equal to 3 into 2, that is equal to 1 into 6, that is equal to 6 into what? 1. 6 can be written in this way as a prime factorization. Therefore alpha 1 plus 1 into alpha 2 plus 1 is equal to 2 into 3, that is equal to 3 into 2, that is equal to 1 into 6, that is equal to 6 into what? 1. Now if alpha 1 plus 1 into alpha 2 plus 1 is equal to 2 into 3, then alpha 1 plus 1 is equal to 2 and alpha 2 plus 1 is equal to what? 3. If these are same, then this one. That is, this gives us alpha 1 is equal to 1 and alpha 2 is equal to what? 2. Therefore n equal to, what is n? 2 raised to alpha 1 into 3 raised to alpha 2. So this is 2 raised to 1 into 3 square. So that will be how much? 18. Now again, if alpha 1 plus 1 into alpha 2 plus 1, that is equal to 3 into 2. If it will be 3 into 2, then alpha 1 plus 1 is equal to 3 and alpha 2 plus 1 is equal to what? 2. So this gives us alpha 1 is equal to 2 and alpha 2 is equal to what? 1. Therefore n equal to 2 raised to alpha 1 into 3 raised to alpha 2. So this is same as 2 square into 3 raised to what? 1. So it will be how much? 12. Again the next one, if alpha 1 plus 1 into alpha 2 plus 1 is equal to what? 1 into 6. Then alpha 1 plus 1 is equal to how much? 1. And alpha 2 plus 1 is equal to what? 6. So this gives alpha 1 is equal to 0 and alpha 2 is equal to how much? 5. Therefore, n is equal to 2 raised to 0 into 3 raised to how much? 5. So 3 raised to 5, so it will be 243. 243. Fine. And the last case, if alpha 1 plus 1 into alpha 2 plus 1 is equal to 6 into 1, then alpha 1 plus 1 is equal to 6 and alpha 2 plus 1 is equal to how much? 1. So this gives us alpha 1 is equal to 5 and alpha 2 is equal to what? 0. Therefore, n is equal to 2 raised to 5 into 3 raised to 0. So that will be how much? 32. Thus among these n, 18, 12, 243 and 32, 12 is the least. So thus we can say 12 is the least positive integers or integer such that what? D of n is equal to what? 6. This is the answer here. As such, we can easily determine this least positive integer n for satisfying our given condition. So this is all about the arithmetic function. In next video, we will see the next function, that is Mobius function. Okay, thank you.